In this video, we're going to derive and discuss the three famous laws of logarithms, which are the main concern of section 6.5, properties of logarithms. We're not going to do any problems in this video. We'll do problems in the next one. So if you just want to get right to the exercises, you can jump ahead. But for now, let's try to understand what these laws mean, where they come from. So I'm going to start out with an example. Observe that log base 2 of 8 is equal to 3, and log base 2 of 16 is equal to 4. Now, why is that true? That's because if we convert to exponential notation, the base 2 to the third power is 8. 2 times 2 times 2 is 8. And the base 2 to the fourth power is 16. If we take 2 times 2 times 2 times 2, we get 16. Now, notice that if I take log base 2 of 8 times 16, so if I multiply 8 times 16, that's log base 2 of 8 times 16 comes out to be 128. And log base 2 of 128 is actually equal to 7. Now that's not totally obvious, but again, it's because since 2 to the 7th equals 128, and we can figure that out on our fingers by taking 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. That's 2 to the 5th. I need 2 more fingers. Times 2 is 64. 64 times 2 is 128. That's 2 to the 7th power. So now, just watch this. I'm going to take log base 2 of 8 times 16, which we just said here is equal to 7. That's equal to log base 2 of 8, which was equal to 3, plus log base 2 of 16, which is equal to 4. 7 is equal to 3 plus 4, so this log base 2 of 8 times 16 is equal to log base 2 of 8 plus log base 2 of 16. What's kind of surprising is that we have times here, we're multiplying, but we have plus here, we're multiplying. I'm sorry, we're adding. We're multiplying here, but adding here. In words, we could say the log of a product is what you get when you multiply two numbers. Log of a product is the sum of the logs. And that's really, in everyday language, that's the gist of one of the famous laws of logarithms. Log of a product, where we're multiplying, is equal to the sum of the logs, where we end up adding. Right, now I'd like to state what the three famous laws are. And let's terabit. So we'll call this the 3 laws of logarithms. So we're going to just write down general statements about what these actually are. We're going to let b, our base, be positive, not equal to 1. We're going to let capital M and capital N be positive numbers, and we're going to let C be any number, and now here's the first law of logarithms. log base b of m times n is equal to log base b of m plus log base b of n. And that's really what we observed in this example that we looked at with some of these powers of 2, some of these logs base 2. But there are 2 more logs, two more laws of logarithms. The second one has to do with log base b of m over n, which you can think of as m divided by n. And it's very analogous to law number 1, where law number 1 involves multiplying here and adding here. Law number 2 involves dividing here. That's going to equal log base b of m minus log base b of n. It involves subtraction over here. So log of the quotient is the difference of the logs. And the third law is a little bit different. Log base b of m to the c power, where c is an exponent, is equal to c times log base b of n. It's like this exponent kind of pops out in front of the log and then just becomes a factor, a number times the log base b of n. So here are 3 laws, and I want to go through a verification of why they're true. And you can skip the verification if you'd like and go right on to the problems. Those will be in our next video. But here's our verification. We're going to start out by, we're going to let u equal log base b of m, and we're going to let v be equal to log base b of n. Now, both of these statements can be rephrased using exponentials, so I'm going to say then base b to the u power is m, and base b to the v power is n. M times n is then equal to b to the u times b to the v. Now b to the u times b to the v, we know, is b to the u plus v. We know we add exponents in that situation. But if m times n is equal to b to the u plus v, we can say log base b of m times n is equal to u plus v. Right? Here's our base. Log base b of this number is equal to that exponent u plus v. But u plus v is just log base b of m plus log base b of n. And there's really our verification of the first law, log base b of the product m times n equals the sum of those logs taken separately. For number 2, if we want to verify the second rule, just notice that m over n is b to the u over b to the v, which is b to the u minus v. And so we can say log base b of m over n is equal to u minus v, which is log base b of m minus log base b of n. And we verified the second law. It's true that the first law of logarithms is related to this law of exponents, where you add exponents. And the second law of logarithms is related to the law of exponents, the situation where you subtract exponents. Now let's just verify number 3. If we look at m to the c power, m to the c power is b to the u to the c. Remember, m was originally, or b to the u is equal to m. And so this is b to the c times u, where I'm multiplying exponents. And now I can turn this back into a logarithm statement. Log base b of m to the c is equal to this exponent, c times u, but that's c times log base b of m. And there we have verified the third law. So in our next video, we're going to do some problems where we apply these laws.